Good morning, guys. Here we are, Wednesday, third lesson of the week, and I'm gonna waste no time getting into this one. Hope you guys did okay on yesterday's lesson with unlike fractions, practicing finding least common denominators. I know it's been a while since we've done a lot of that, but it's good practice to do. Today, we're gonna be adding and subtracting mixed numbers. That's numbers with whole numbers and fractions in them. And some of them can be a little bit difficult, so I'm going to spend a little bit of time especially showing you the subtraction ones. The addition ones seem to be okay. I think you'll be just fine with those. But let's jump into it. We're going to start here with problem number 1 on the sheet that I'm linking today. And again, remember, as I keep reminding you, but I still have some people telling me they can't print out the sheets. That's fine. Just write down what you see on this screen right here. Okay? Write that down right now. Go ahead and pause the video if you need to. Write down the problems and then just do them along with me. Okay, the first one we're going to do here is number 1, and that's 2 3/5 plus 1 4/5. This is nice because when you're adding and subtracting fractions, you have to have a common denominator, and these already do. So these are like fractions. But before we do anything with mixed numbers, make sure you always get a quick estimate in your head first before you go diving into a problem like this, because you want to make sure you're reasonable. Remember, that's the most important thing about mathematics, so we get from any of this is to be reasonable people, right? So 2 3/5 is about 2.5, and 1 4/5 is almost 2. So my estimate might be 4.5, somewhere under 5. Okay, so as long as I know that's a pretty good estimate, I'm gonna go roll with that, and I'm gonna continue to solve the problem. Now here's what you do when adding and subtracting mixed numbers or mixed numbers. You have to add the whole numbers and the fractions together separately. Okay, so what we'll first do here is we're going to add these two whole numbers together, right? 2 plus 1 is 3. And since the denominators are the same, we didn't have to change them. We don't have to worry about that. We're going to go ahead and add the fractions together. 3/5 and 4/5 is 7/5. Hopefully some of you guys are catching that's not our answer yet because it's not simplified. We have an improper fraction right here, right? Covering up the 3 here, we've got a 7/5 that needs to be simplified. 7/5 is improper, so what we have to do is divide, right? 7 divided by 5, obviously 5/5 is one whole, so that's going to be 7/5 would come out to be 1 2/5. But, and here's a big mistake a lot of people make, is that once they simplify 7/5 to 1 2/5, they forgot about their 3 that they had right here. So make sure you add that 3 to it, which would really make this 4 2/5. And I said it was going to be close to 4.5. That was my estimate. This is close to 4.5. And remember, when we get estimates, that does not mean that because our answer is close to it, it is correct. It just means it's reasonable, which is a really good thing, and I'm going to roll with it. I think 4 2/5 is my answer to that problem. Then we're going to jump over to number 2, a subtraction problem. 3 5/6 minus 1 1/6. Oops. 3 5/6 minus 1 1/6. Hopefully that's not too messy for you guys. Again, common denominators. This is cool. This is good for us. So let's go ahead and subtract the whole numbers. 3 minus 1 is 2, and 5/6 minus 1/6 is 4/6. Nice and easy. Okay, subtract the whole numbers and the fractions. But we have an issue. This fraction can be simplified. 4 and 6 can both be divided down by 2. So instead of 2 and 4/6, we're going to have 2 2/3 for our answer on number 2. 2 2/3. Now we're going to bounce around a little bit here. And we are going to go down and we are going to solve number 6. Okay? Because the rest of these are very similar to the ones we just did, just regular adding and subtracting. On number 3 here, you do have to find a common denominator, but I have a strong feeling you guys would be okay with that. But I do want to jump down here to number 6 and take a look at this. 3 5/8 minus 2 7/8. 3 5/8 minus 2 7/8. So we have common denominators. Okay, so this means we can just go ahead and start subtracting. If we do 3 minus 2, we get 1. But if we do 5/8 minus 7/8, we have a problem. You cannot do 5/8 minus 7/8. You don't have 7/8 to take away. You only have 5. So we have a problem. And that problem is we don't have enough 8s. So we literally can't subtract this. Now I'm going to show you visually what happens here, because this is the most confusing part of adding and subtracting mixed numbers. I'm going to show you what 3 and 5/8 looks like real quick. 1, 2, 3, and we're going to need some 8s. So here's 3 wholes, right? And then we got 8s right here. 1, 2, 3, 4, 5, 8. So there's 3 and 5/8. And over here we're going to have 2, 2, 3, 4, 5, 6, 7. There we go. 2 and 1, 2, 3, 4, 5, 6. 2 and 7/8. Now we could take 2 and 7/8 away from this, obviously, because this whole amount right here is less than this. So we can take it away. But the problem is we've got 5/8 trying to take away 7/8. So what do we do? How do we get the amount of 8s we need to be able to take away 7/8? Here's how. Because you can't take these 7/8 away from these 5/8, that's okay, because we have more stuff you can take away from here. Check this out. I'm going to take one of these wholes that we have here, one of the 3s, and I'm going to go ahead and make it into 8s. Now what I've done is essentially I've taken 3 and 5/8 and turned it into 2 and 13/8, right? Because there's 8/8 and 5/8 more, right? I've turned it into 2 and 13/8. Now that's improper, but that's okay. If I turn this into 2 and 13/8 like that, because as you can see it's still equivalent, I didn't change anything. I just turned one of these wholes into 8s. I turned it to 2 and 13/8 because now I can subtract 2 and 7/8 from it, right? So all I did was take this whole number 3, I took one of the wholes there and turned it into 8/8 and just put it over here so I could then subtract it. So now you can do the subtraction. 2 minus 2 is 0, and 13/8 minus 7/8 is 6/8, which simplifies down to 3/4. I know that's a little confusing, and if you have to rewatch that little part of the video, please do. But now I'm going to show you what you can do. You don't have to draw it visually like this. I'm going to show that problem to you one more time. 3 and 5/8 minus 2 and 7/8. If I run into an issue where I've got to subtract, and I don't have enough to subtract from, because 5/8 minus 7/8 is not 2/8. Okay, 5 minus 7 is not 2. You're thinking backwards. What you should do is go ahead and borrow 1 from the whole number. Make that a 2. Just like we did over here. Borrowed 1 from it. But then we have to take 8/8, because that's what a whole is, right? One that we take away from it. 8/8, and add it to your 5/8 right here. So we'll do 2 and 8/8, which is 3, because 8/8 is 1 whole. That's 3. We add that to our 5/8 that we already have right here. So this is the same amount. I'm just writing it a little bit differently. To 2 and 13/8 minus 2 and 7/8, which got us to our answer of 3/4. Okay? Hopefully that helps. And our answer to number 6 was 3/4. Here's what I'm going to do. I want you guys to try one of those on your own. How about you guys try number 7 on your own right now. Pause the video. See if you can do that. 7 and 5/12 minus 3 and 3/4. See if you can do that one on your own. And then unpause the video and see if you got it right. gotta subtract, but I can't subtract unless the denominators are common. So I need to change the denominator to a common one, and the least common multiple of 12 and 4 is 12. So 7 and 5 twelfths will stay the same. But the denominator over here needs to be changed to 12. So 4 was multiplied by 3 to get to 12. So 3 times 3 will give me 9. So there, that's an equivalent fraction. Now I have common denominators. Now I need to subtract. 7 minus 3 is 4, and 5 twelfths minus 9 twelfths is... crap. You can't take 9 away from 5. Where would I find more twelfths? I only have 5 twelfths, I need more twelfths. Huh. I bet this 7 has some twelfths. I'll just borrow some from him, right? I'll make him a 6, so I'll take 1 whole away from him. That's 12 twelfths. So 12 twelfths plus the 5 twelfths I have gives me 17 twelfths. So those are the same. Same amount, not the same thing, they're the same amount, so that's equivalent, so that's good. Minus 3 and 9 twelfths. Now I can subtract it. 6 minus 3 is 3. 17 minus 9 is 8. Answer is 3 and 8 twelfths. Always got to remember the last thing I do before I put my answer of a fraction down and make sure it's simplified. 8 and 12 can both be divided by 4 because that's their greatest common factor. So that's 3 and 2 thirds. Final answer. I hope you guys did well today, and I hope that that's enough content right there in this video that you guys can rewatch if you're a little bit confused. A lot of it has to do with what we did yesterday. Hopefully you guys did well with it. 3 and 2/3 is our answer to number 7. Let me know if you got any questions. I'm going to put a couple of these up, probably just about 3 or 4 of them on a Google form for you guys to practice, and that'll be it for this week. Bye.